Greetings, fellow mathematicians. This is Mr. Kingsbury from Algebra 2. We're talking about quadratics, and today I want to focus on the quadratic formula. The question we're going to answer is, how do I solve a quadratic equation using the quadratic formula? I think it's a great question. You're going to see me break it down. Before we can talk about how to use it, first we should probably identify what is it. Well, it's a formula that looks like this. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I know when you look at that, it's a little overwhelming, right? Probably you're asking yourself, Mr. Kingsbury, that looks wonderful, but where do we get all these a's and b's and c's from? Well, they come from the standard form of a quadratic equation, which is ax squared plus bx plus c equals y. So the coefficients and the constant from the equation get plugged into the formula, and it gives us our answers. Now, in a previous video, we discussed the discriminant, which is this part, and the discriminant is going to tell us if there are two real solutions, two complex solutions, or one real solution. And we'll talk about that as we go through the process. One other thing, though, I want to mention before we get into actually working problems with the quadratic formula is I want to say this. The quadratic formula is the end-all, be-all. If there are solutions to a problem, or even if there aren't, the quadratic formula can find them. And what I mean is, when I say even if there aren't, the quadratic formula will help you figure out that there are not real solutions, or there are imaginary solutions, or there aren't any. Actually, there's either complex or real solutions. So either way, no matter what your equation is, the quadratic formula can find the answers. Now, there are other methods like completing the square or factoring that you can use, but they really only work when the answers are a little bit nicer. This works for everything and anything. So let me show you. I'm going to do 3 examples so that you can see the 3 different possibilities and how to handle them. And they're all going to start out real similar. So let's start with example 1. We'll work with the simple, or we'll start with the simple and work to the sublime. So let's say that I give you the following equation. Let's say y equals x squared plus 5x minus 6. Now, what I'd like to do before I figure out the quadratic stuff is I want to identify what my A, B, and C are. And actually, I have a whole list of things that I'm going to identify. Now, I don't know how you were shown in Algebra 1 to do this. I know when I taught Algebra 1, I tended to overload the students by putting the formula and then substituting right in and doing a little simplifying here and there, and it seemed like magic. And unfortunately, the students got very lost. They weren't sure what they were supposed to do next. Where should I start? What's my next move? It got very complex. So over the years, I've developed this pretty cool system that I think you're going to like. So we need to identify A, B, and C. But you'll note there are some other things as well, like B squared, 2A, and 4AC. So I'm going to identify all of these things. Let's start with A. A will be the coefficient of x squared, which in this case happens to be 1. Remember, if there isn't an explicitly written out coefficient, like 5 is explicitly written out, if there's not a number written here, we assume it's 1. And then I want to know what 2a is. Well, this is just 2 times a. So 2 times a is 2a. That means 2 times 1, that's the other side, that's going to be 2. What's b? B will be the coefficient of x. In this case, it's 5. And I want to know what c is. C is going to be the constant on the end here, negative 6. And then I'm going to do a couple other things. So we know what b is. Actually, you know what? Let's do this. If b is 5, b squared will be 5 squared, which is 25. And then let's put c, which is negative 6. And let's do 4ac. That's going to be 4 times 1 times negative 6. Making it easy here. So let's see. 4 times 1 is 4 times negative 6 is negative 24. So I'm doing all these little pieces because the next thing I'm going to do then is I'm going to ask, or I'm going to see what b squared minus 4ac is. That's my discriminant, if you'll recall from a previous video. Well, I know b squared is 25, and 4ac is negative 24, and minus a negative. Two negatives make a positive, so I get 49. That means there will be two real solutions. Positive discriminant, two real solutions. Next up, then, I'm going to use this, and you're going to really like this. This is the formula, so I'm going to write x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. But check this out. B is 5, so the opposite of that is negative 5. This is the cool part. Plus or minus b squared minus 4ac. We know what that is. We figured it out. It's 49. And 2a, we know what that is. It's right here. It's 2. So what I've done is I've substituted a bunch of stuff, and I managed to do a little simplifying as we've been working through here so that my work is already partially done for me. The next thing I would do is square root this number. Now, most of the problems I give you, you'll probably be able to take the square root no problem. So in this case, we can do that. In the cases that you can't, I'll probably just have you leave it like this. That way it's very accurate. In this case, though, we can square root 49, and that's going to be 7. So I have negative 5 plus or minus 7 over 2. And then we can figure out what our two solutions are. So see how there's a plus or a minus? That means there's two options. Either x equals negative 5 plus 7 over 2, or x equals negative 5 minus 7 over 2. So I can figure out what both of those are, and I get my two solutions. So negative 5 plus 7 is 2. And on the bottom, I still have the other 2. 2 divided by 2 is 1. Down here, negative 5 minus 7 is negative 12. Still over 2. Negative 12 divided by 2 is negative 6. So my solutions are x equals 1 and x equals negative 6. And I'm done. Those are my solutions. Now, what was nice is when I knew that I was going to have two real numbers, I knew that at some point I was going to have to split this. It prepared me for what was coming. What was also nice is by finding b squared minus 4ac, I had something to plug in under the square root, and I didn't have to re-plug in all these numbers and figure them out. It's kind of nice. So there's one example. Let's do another example. And I think you're going to like this one too. So here's example 2. Let's say I give you y equals x squared minus 6x plus 9. And I'm going to do just like I did before. I'm going to figure out what a is. A is going to be 1. I'm going to figure out what 2a is. 2a would be 2 times 1. That's 2. B is going to be negative 6. That means b squared will be negative 6 squared, which is positive 36. A negative times a negative is a positive. If you put this in your calculator and you square it and you don't put parentheses outside the negative 6 part, before you square it, you will get a negative 36, which is wrong. Please be careful. Sorry for the yawn. C is going to be 9. Let's see. And we need to do 4ac. So that's going to be 4 times 1 is 4 times c is 36. Now let's fill in the parts. So first we're going to figure out what b squared minus 4ac is. Well, b squared is 36. Minus 4ac. 4ac is also 36. 36 minus 36 is 0. That means we have one solution. What does this mean? It means I know that underneath my radical sign is going to be a 0. And when I take the square root of 0, I'm going to get 0. And that means I am both adding and subtracting 0 to the negative b part, and neither of those affect anything. You'll see what I mean. This tells me, though, that I'm not going to have to pull my answer apart like I did for this first problem up here, where I had to set up both possibilities. I'm only going to have one possibility, so I don't need to set up more than one. Yeah, you'll see. So let's do this. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. B is negative 6. The opposite of that would be positive 6. And then we have plus or minus b squared minus 4ac, which we know equals 0. And that's over 2a. 2a is 2. Now, something interesting is going to happen. The square root of 0 is 0. So I get 6 plus or minus 0 over 2. And 0 has a very unique property, and that is it is the only number that we can add or subtract from a letter, and it's okay. It also can be added or subtracted to anything, and it changes nothing. Think about it. If you take 5 and you add 0, you still have 5. If you take 27 and you subtract 0, you still have 27. So right here, whether I do 6 plus 0 or 6 minus 0, I'm going to end up with 6 no matter what. And that'll be 6 over 2, which is 3. So my answer will be 3. See? Not a big deal. Let me do one more and then I'll get out of your hair. Last example. You like how I have my next page set up already? I knew that was going to happen. So I was like, yo, I am going to get this thing set up beforehand. And I'm glad that I did. All right, here's our last one. We've got y equals 2x squared plus 4x minus 3. Not 3. I'm sorry, not minus 3. How about plus 10? Alrighty, so a is 2, which makes 2a 4. 2 times 2 is 4. B is also 4, which makes b squared, whatever 4 squared is, which is 16. C will be 10. And last but not least, 4ac. That's going to be 4 times 2 is 8, times 10 is 80. So far, so good. So we're going to use this. X equals the opposite. No, we're not there yet. My bad. Let's do b squared minus 4ac. That's what we should do first. B squared is 16. 4ac is 80. So I have 16 minus 80, which is negative 64. That means there will be 2 complex solutions. Now that's important to me because that lets me know at some point I'm going to have to take the 2 parts of the in the top or in the numerator of my answer, and I'm going to have to divide them individually. I'll show you what that means, but this lets me know that my answer is going to have 2 pieces instead of just 1. Okay, so now let's use this. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Oh my gosh, that's a mouthful. B is 4. The opposite of 4 is negative 4. Plus or minus the square root of b squared minus 4ac, which is negative 64. And that's over 2a. 2a will be 4. Next up, I'm supposed to square root 64. Now, if this was just 64, I could square root it and get 8. But it's not. It's negative 64. Now, at this point, we've talked about square roots in class and square roots of negative numbers. And really, the only difference between square rooting a positive number and square rooting a negative number is that the negative number gets an I after it. Here's what I mean. When we take the square root of negative 64, it's just like taking the square root of 64. There's going to be an 8. But because it's negative, I'm going to put an I after it. Remember, the square root of negative 1 is I, and 64 is like, negative 64 is the result of multiplying positive 64 and negative 1. Anyway, just go with it. The square root of negative 64 would be 8i. So I end up with negative 4 plus or minus 8i over 4. Now remember I talked about having to split this thing up? This is where I do that. And I'm going to rewrite this as negative 4 over 4 plus or minus 8 over 4i. And then I'm going to simplify it. Negative 4 divided by 4 is negative 1. And then I'll put plus or minus. 8 divided by 4 is 2. So I get negative 1 plus or minus 2i. And that's my complex solutions right there. That's all there is to it, ladies and gentlemen. I will see you in class.